So I'll start with brain teasers, because you're going to have to warm your brains up in order to follow what it is that I'm going to say to you. So these are little word games, okay? There's one example and then 5 of the other ones, and see if we can figure out what they are. Does anyone want to figure out what that is? It's a history repeats itself. Very good. That's the easy one. Or maybe for some people, these will probably come pretty quick. Whoops, let's go back. Read between, this is a sharp group. Number 2, balanced meal, very good. Bland is split, okay, it took a little bit longer. Isn't that good? That's funny, isn't it? That's fun. Oh, here we go. Oh, my goodness, very good. Safety in numbers. S-A-F-E-T-Y in the numbers. Wow, that is really good. This is my favorite. Ring around a rosy, okay. Now the brain's working. Isn't that fun? That's better than jokes anyway, right? Yeah. Okay. All warmed up? Let's begin. The first laser was in 1960. And it operated via short pulses of light. And it was also known as the first optical maser. Before the laser, we had the maser. And laser is an acronym that stands for light amplification by stimulated emission of radiation. Maser, of course, replaced the L that stands for light with M, microwave amplification. So they had microwave. It wasn't in the visible part of the spectrum. And they said, let's see if we can get the same type of an action to take place in the visible part of the spectrum. So they came up with a laser. And it was a pulsed laser. About 20 nanoseconds were the pulses. That's 20 billionths of a second. If you want to know how fast 20 billionths of a second is, you can compare it to a fighter jet traveling through the sky at full throttle. And in the amount of time of 20 nanoseconds, it will move forward only a fraction of one of its atoms. So that's how fast 20 nanoseconds is. It's extremely fast. Oh, it keeps going twice, okay. Now the first gas laser was in 1960 as well, and it was a continuous wave output, which was the helium neon laser. Does anybody want to take a guess at what type of gases were contained within a helium neon laser? Oh, it's close. Helium and neon, yeah, see, it's really, all of this is really a lot simpler than what it seems. There are argon lasers with what type of gas in them? Argon. What is a laser? Okay, the lasing medium can be solid, liquid, or gas. It creates a special type of light that is monochromatic, which means one frequency or color, and it's coherent, which means that all waves are in step with each other. The lights that we have coming in the room, they do not have the photons coming out in step with one another, and they're very random in nature. It's needed to make a hologram, but it's not needed to view a hologram. And what is a hologram? A hologram is a true three-dimensional record of the object or scene being recorded. It contains information on the size, the shape, and the dimensional properties of what's being recorded. And it's created in a special laser lab. Now, the highest resolution imaging technology in the world today is holography, up to 10,000 lines per millimeter. And Dr. Dennis Gabor received the Nobel Prize for holography in 1971. So it's a very well-respected field in physics. The first laser hologram with Emmett Leith and Juris Upetniks was 1963. And looking down on a holography table, we'll see what it is that it takes to make a hologram. And they have a holography lab here, actually. It's a very heavy table. When I had my lab, which I unfortunately do not have anymore, it weighed 1.5 tons. My table weighed 1.5 tons and floated on air, because you can't have any vibration whatsoever. It'll ruin the hologram during the exposure. You need your laser beam, which you can see here, looking down onto the table, mirrors, lenses, film holder, and the object, which is the chessboard. And how we make a hologram. It was first known as laser photography. Let's just say it's one of these objects that we have a hologram over here. You can see that the laser beam travels down the table, hits a mirror. It goes through this, oh, you know what? This is 2017. Let's use a laser pointer. It goes through this object right here, which is called a beam splitter. And just to show how difficult this field is, the beam splitter actually splits the beam. So that's how they came up with that name for that. 50% of the light hits the mirror, travels through a lens, illuminates the object. 50% of the other light travels down, goes through another lens, and goes directly to the plate. Now it's the interference of these two waves, the wave that's coming off and being reflected off the object, and the beam that's being reflected and going directly to the plate. When those two things interfere with one another, that's what takes place at the holographic plate. There's no image on a hologram. When you see these images over here lit up, as real as they look. And look around the back of them too, because they're really only thin. When you look at these images, you have to realize there's no image there per se. It's actually just an interference pattern. That interference pattern takes the light, sends it to the eyes sends it to the brain, and it's a mathematical process that takes place within the brain itself that puts that image. So it's hard to say whether we all see the same thing or not, because it's the brain interpretation of the information that's coming from the hologram.